Hey guys, I'm Oscar Rivera, and welcome to another episode of BAM! Math. Oh god.
Alright, what's up dudes? Let's do some math. So for this problem, we have to go ahead and find the equation of the tangent line to f of x equals x squared plus 1 at the point where x equals 1. Alright, so let's get that out the way. Wow, that was smooth. I just threw that eraser on the ground. Alright, so first let's plug in 1 to our into the x value of our equation. So that'll go ahead and give us f of 1 equals x, which is pretty much 1. Let's pretend I did not just do that. 1 squared plus 1. Alright, so we can condense this down to f of 1 equals 2. Alright, so that means that our point of contact, which is the point where that tangent line touches, is going to be x value 1, y value 2. Woo! Alright, more erasing. Alright, next let's find the derivative of the whole equation. So that means that if f of x equals x squared plus 1, then obviously the derivative of this is going to be f prime x equals 2x, and then that's a constant, so it's 0. So yeah, don't hit me, Mr. Carindang. Not again. Alright, now that we have that, we can just go ahead and plug in our given x value into that equation for the derivative. So our x value is 1, which means that f prime 1 equals 2, 1. So then that just gives you 2. Alright, now that's going to go ahead and be the slope of our tangent line. So let's go ahead and erase that one more time. Alright, now with these given values, we can just go ahead and plug that into the slope formula, which, as we all know, is y minus y1 over x minus x1. Alright, so let's go ahead and plug our values in. So y minus 2 over x minus 1. Oh, and I forgot to put up here that that equals m, which is our slope or gradient or whatever other word you want to use for it. So in this equation, like we found out, it equals 2. Now we can go ahead and condense this down to y minus 2 equals 2x plus minus 2. And then we can just condense that down even more into its final form of y equals 2x. And that, ladies and gentlemen, is the equation of the tangent line to f of x equals x squared plus 1 at the point where x equals 1. Bam! Math. Alright, what's up little nuggets? Time for the next problem. Alright, for this one we're going to be finding the equation of the normal to y equals 8 over x square root of x at the point where x equals 4. Alright, now keep in mind we're finding the normal this time. That's not the tangent, that is actually perpendicular to the tangent, so it's going to be kind of like bam. Alright, so like in the last problem, our first step is going to be to plug in our x value into the x in the equation. So that's going to make it to where y equals 8 over square root of 4, which then condenses down to 8 over 2, which is just 4. Alright, so our y is 4, which means that our point of contact is x value 4, y value 4. Alright, go ahead and erase that with the eraser of math, and then write some more stuff with the marker of math. Alright, so let's go ahead and rewrite our equation first. So original one is, let's go ahead. I like f of x better, don't judge me. I have my reasons. F of x equals 8 over square root of x. So let's go ahead and rewrite that into f of x equals 8x to the negative 1/2. Because in the end, it's the same thing. Don't ask me why. There's math reasons behind it. Go ask, like, Archimedes or something. All right. So let's go ahead. Let's go ahead and find the derivative of this equation here. So it's going to be f prime x equals negative 4x to the negative 3/2. There we go. All right, now that we have that, let's actually go ahead and plug in our x value from that, since it is at the point x equals 4. So let's plug in our x value of 4. So f prime 4 equals negative 4 times 4 to the negative 3/2. All right, and after some math activities and math processes, we're just going to go ahead and say that f prime 4 is actually equal to negative 1/2. Bam, magic. All right, let's erase that with the eraser of math one more time. And now that we have that, let's actually keep in mind that that negative 1/2 that we found is actually the slope for the tangent line. Tangent. I'm not going to finish writing that, just pretend that says tangent. All right, so what we need to do is actually find the negative reciprocal of this, and that'll be our normal line slope. So normal line, bam, that is the negative reciprocal, which is 2. Alright, so just like in that other equation, let's just plug it back into our slope formula, which again was y minus y1 over x minus x1 equals m, which is the slope or gradient or whatever you like to call it in your country. We don't judge, we're an international school, that's cool. Alright, so that's pretty much going to go ahead and give us y minus 4 over x minus 4 equals 2, which is blah 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 blah. You shrink that down into y equals 2x minus 4. Now that's just a condensed version of that, simplified and everything, but here we go. That is the equation to your normal line, and one more time, bam, math. What's up, guys? One last time, third time, please don't cry. I know this is our farewell problem, but it's gonna be fun, so don't worry. Not really. I'm just kind of doing this because I have to. Just kidding. I love math. It's actually pretty cool. Alright, so for this problem, we're gonna find the equations of any horizontal tangents to y equals x to the third minus 12x plus 2. Alright, so for this one, we don't have to plug anything into anything because we're not giving a certain point. We're just told horizontal tangents. That's anything that looks like that, pretty much. Yeah, so if that's a curve, those are the horizontal tangents because they touch here and here. Don't ask me how I know that, it's science. Alright, so first step in this is to go ahead and find the derivative of this equation here. So let's go ahead and do that. So y prime equals 3x to the second power minus 12, and that's it. That's pretty much it. Yeah, there's your derivative. All right. So in order to find the horizontal tangents, all you have to do is find the spots where the slope equals 0. And hey, if only we had an equation that gives you the slopes of things, bam, we do this thing here, this thing here, this thing here, that thing there. Yep. The slopes are found by the derivative. So there we go. All we have to do is set this equal to 0, and bam, we will have our y values, which in turn just give us our horizontal tangent equations. Alright, so let's use the eraser of math for this thing. Okay, done with the eraser of math. Alright, so let's make things equal to 0. So first, let's just take our derivative equation, or derived equation. There we go, that's a proper terminology. So f of x equals 3x squared minus 12. Alright, we can go ahead and simplify this into f of x, f prime x equals blah 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 3 x squared minus 4. Then you do some more math, and you're at 3 x plus 2 x negative 2. You see, Mr. Karendang, I can factor. It only took me like 3 years to learn. Alright, so from this, obviously, the points where it equals 0 are going to be at x equals negative 2 and x equals positive 2. Ooh. No, we're not done yet. Just kidding. I didn't put that in a big rectangle, because that's what I do when I'm done with things. I put them in a big rectangle. Alright, so now that we have those x values, all we have to do is simply plug them into that original equation, which again was f of x equals x cubed minus 12x plus 2. Alright, so let's go ahead and plug in 2 to that. Blah blah blah. I wish we had some elevator music, but unfortunately we don't, and I probably won't edit any into this, so just kind of bear with me, guys. Alright? Okay, so the math magic, no, Gleb, don't put elevator music in the background. Alright, so the math magic tells us that this is actually 14. So there we go. That's our first y value. Let's go ahead and find our second one. So I'm really lazy. So let's go ahead and just use this one here instead of rewriting things. Alright, so let's plug in negative 2 this time. Negative 2, negative 2. Alright, so then once we simplify this, it's going to go ahead and give us 18. So we go ahead and just learn that our points of contact are actually at these 2 points. 1 second. Alright, so that first one we plugged in was 2, and it gave us negative 14. So our point of contact for that one is going to be 2 comma negative 14, and for this next one we plugged in negative 2 and we got 18. So that next point of contact is negative 2 comma 18. Alright, so from this we pretty much see, and if you don't know how to find equations for straight lines, then wow, you are, not the smartest kid alive. But hey, if you're not, let's just go ahead and remind you, okay? So just knowing that, we know that these are the points of contact for the horizontal tangent lines, which means they look like this, which means that their equations would just be y equals, bring that down, negative 14, and then y equals 18. So those are our equations, and if we go ahead and plot it over here, let's say that was our curve, let's say this is our curve, then that means that this line here is y equals 18, and this line here is going to be y equals 14. And that's your math. You're welcome. That says negative 14. Yep. And other than that, that's pretty much it. Bam, math.